Hello students, please let me know, am I audible properly? Yes. So namaste and welcome to the oliveboard platform once again. This is Vipin, one of the quant educator at oliveboard platform. How are you? So I hope you are well. Today we are going to start algebra part 2nd. So let's start without wasting the time. So could you tell me what would be the answer of this question? Yes, please try this question. So I will tell you both way, right? Conceptual way as well as short trick or exam approach, right? So just try this question and tell me what would be the answer of this question. Yes, please. See, I can write it 3.7 to the power x is equal to 0.037 to the power y is equal to, see, 10,000 we can write how many zeros after 1? So 1, 2, 3, 4. So we can write it 10 to the power 4. So I hope there is no problem in this. Yes. See, now we can say that this portion is equal to this is equal to this. So we can take 3.7 to the power x is equal to 10 to the power 4, right? And here we can say that 0.037 to the power y is equal to 10 to the power 4. I am explaining with the basic concept, how we will do this question with the basic concept on. Okay, see, 3.7 to the power x is equal to 10 to the power 4. Okay, so transfer x to the right hand side. So whenever we are transferring power, right, so it is reciprocated, means 3.7 would be equal to 10 to the power 4 by x. Clear? And here we can say that 0.037 would be equal to 10 to the power 4 upon y. No problem. See, here is 3.7, here is 0.037. So what we need to do? Here we have to move the decimal towards the right hand side to the two basis point. Okay. So we will multiply both sides by the 100. Okay. If we multiply by 100, or we can say that 10 to the power 2. 10 to the power 2 in both sides. So nothing will change. So we can say that when the 10 to the power 2, 100 will be multiplied. So it will become, the point will be shifted to the two basis point to the right side. Okay, towards the right side. So it will become 3.7 is equal to same base. So the power will get added. So 4 upon y plus 2, right? So we can say that this is equation 1 and this is equation 2. So from both equation we can say that we have the value, see, we have the value of 3.7 here, 3.7 here. So after comparing we can say that 10 to the power 4 upon x would be equal to the 10 to the power 4 upon y plus 2, right? See, base are same, so it will be they will be cancelled. So we can compare. So the power would be equal. So 4 upon x would be equal to 4 upon y plus 2, right? So transfer 4 upon y to the left side. So I will get 4. What is the smart approach to do this? Okay, see, 3.7 to the power x is equal to 0. See, what we can do? So we have to focus how many, see, what is the procedure? 3.7 to the power x is equal to 0.037 to the power y is equal to 10 to the power 4. Yes. See, we have to count how many zeros after decimal. So in first base, there are one digit. There are one digit after decimal. There are one digit after decimal. Here, 3 digit after decimal. 3 digits after decimal. After decimal. See, so the maximum number of digits after decimal are in this portion, right? So just focus what is the power in variable. So power of the maximum number of digit after decimal is y. So this portion must be negative, right? So directly you can say that after reciprocating, this must be negative, right? And the less number of digit variable must be positive, right? So here we can say that I will get the answer 1 upon x minus 1 upon y directly. So whatever is the power of 10. Yes, please tell me. What would be the answer for this question? See, so directly here we can say that so maximum number of digit are there in this second portion. So just focus on the power. So the maximum number of digits base power must be negative, right? So it would be 1 upon y. So this must be negative, right? So directly we can say that 1 upon x minus 1 upon y is equal to what? So we can write it 10 to the power 4. So take the number, take the difference of number of digit after decimal, right? So there are 2. So we can say that 1 upon x minus 1 upon y is equal to 1 by 2, right? So this would be, yes. Now the question is asking what is the value of 5 upon x minus 5 upon y. So just multiply by 5 on both sides, right? So just now everything okay? Sound is okay? See, so the value for 1 upon y minus 1 upon x. So it would be just multiply by minus 1 in both sides, right? In this, right? Or take minus common. It's up to you. So the answer would be minus 1 by 2. Answer would be minus 1 by 2. Clear? Yes. So tell me one thing. If I say that if 0.51 to the power x is equal to 0.00051 to the power y is equal to 10 to the power 9. So tell me what would be the value for 1 upon x minus 1 upon y, second 1 upon y minus 1 upon x. See, I have already told you the basic concept. So what is the exam approach of solving this type of question? So first of all, we have to focus on the base in which number of digit after decimal are highest. Okay, number of digit after decimal are highest. So here are 1, 2, 3, 4, 5 digit after decimal. So here we have 5 digits after decimal. Here we have 2 digits after decimal. Okay, so the number of digits after decimal here is the highest. So the power, whatever variable is in the power, right? So that must be in negative, right? So it means we will get the answer for this directly. So what would be the answer? So whatever is the power of 10, just write it in the denominator, and whatever is the difference between the digit after the decimal, right? So here the difference is what? Here the difference is 3. So 3 will come to the numerator.
So this is the right answer. So 1 upon 3 is the right answer. For 1 upon y minus 1 upon x, the answer would be minus 1 by 3. Simple. Answer would be minus 1 by 3. So I hope this thing is very much clear. Now tell me what would be the answer for this question. Yes, please. Try this question and please write the answer in the comment box. See, here simply we can say that 1, 2, 3, 4, 5, 6, 7. So we can write 10 to the power 7, right? See, so the answer for 1 upon x minus 1 upon y would be, so just write the power of 10 in the denominator. So take the difference between the number of digit after decimal. So here are 2, here is 5, right? Here is 5. So 5 minus 2, 3. So 3 by 7 is the right answer. 3 by 7 is the right answer. So here it will become 3 by 7 plus 2, right? So we can say that 7 is the LCM. So 3 plus 14, that is 17. So this will become 17 by 7, right? So this will become 17 by 7, right? See, 1 upon y minus 1 upon x. So answer would be minus 3 by 7. Simple. Answer would be minus 3 by 7. Yes. Simple. Yes, please tell me what would be the answer. See, here the number of digits after decimal 5, here is 3. So the maximum number of digit base is this. So power of this is x. So this must be negative, right? So this time minus x. So it must be minus 1 upon. So I will get the positive answer for this, right? So take how many? So what is the power of 10? So 1, 2, 3, 4, 5, 6, 7, 8. So I will write in the denominator. So we can write it 10 to the power 8. So whatever is the power of 10, I will take it in the denominator. Okay. So simply take the difference of number of digit after decimal. So here is 2. So we can say that 1 upon 4 is the right answer. And for 1 upon x minus 1 upon y, so the answer would be what? Minus 1 upon 4, right? Here. So minus 1 upon 4 plus 3. So this would be equal to minus 1 plus 12 divided by 4. So 11 by 4 is the right answer. 11 by 4 is the right answer. I hope the thing is very much clear. So let's move to the another type. Very important question. Now tell me what would be the answer for this question. So again there are two approaches. One is basic and one is exam approach or direct short trick. So I will tell you both, okay? I will tell you both. See, so just first focus on the basic approach. So we can say that let 3 to the power x is equal to 5 to the power y is equal to 15 to the power z. So this would be equal to k. This would be equal to k. Simple. This would be equal to k. So here we can write it 3 to the power x is equal to k, 5 to the power y is equal to k, and 15 to the power z is equal to k. So we can say that 3 is equal to k to the power 1 upon x, 5 is equal to k to the power 1 upon y, and 15 is equal to k to the power 1 upon z. Simply we can write this. Yes. See, now focus on the base which have maximum number, or we can say focus on the highest base, right? So we will focus on this. Okay. So we can say that we can write 15. See, we can write 15. So 15 to the power 1 is equal to, we can write it 3 to the power. See, we are going to take this, right? See, we are going to take this part. So we can write 15 as 3 into 5 is equal to k to the power 1 upon z. Simple. Is this clear? So we can say that So substitute the value of 3 and 5. So 3 is equal to what? K to the power 1 upon x. So here we can write k to the power 1 upon x into 5 is equal to k to the power 1 upon y, right? So substitute the value. So simply we can say that the base is same, so power will be added, okay? So it will become k to the power 1 upon x plus 1 upon y is equal to k to the power 1 upon z. So base is same, so it will be cancelled. So directly we can say that here 1 upon x plus 1 upon y is equal to 1 upon z. So this is the relationship between x, y and z, right? So relationship between x, y, z is what? 1 upon x plus 1 upon y is equal to 1 upon z, right? So what is the value of z in terms of x, y? So we can say that take the LCM. So x, y, so y plus x is equal to 1 upon z. So z is equal to what? So we can say that z is equal to xy upon x plus y. Simple? Yes. See. So what is the direct approach? So just focus on the highest base. So this is the highest base. This is the highest base. So just focus on the highest base. So highest base number is this, right? So we can write 15 to the power 1 is equal to, in the power form, so 3 to the power 1 into 5 to the power 1. So now compare the power, okay? So numerical power will always come in the numerator and variable power I will take in denominator directly. So this is the direct approach which I am going to tell you. See here the power of 15 is 1. So power of 15 is z. So 1 upon z is equal to, here the power of 3 is 1. So here the power of 3 is x. Then plus power of 5 is 1, power of 5 is y. So we can say that the relationship between x, y, z is equal to 1 upon z is equal to 1 upon x plus 1 upon y. Directly we can write. So we can say that 1 upon z is equal to, just take the LCM, x, y. So it is equal to y plus x. Just reciprocate. So we can say that z is equal to xy upon x plus y. Z is equal to xy upon x plus y. Simple? Yes, no problem. So I hope this is very much clear. Now try this question and do this question smart approach, with the smart approach, right? See, I'm going to tell you again, right? See, whenever we get such type of question, right, so we have to focus on the base which is highest, which is having highest base, right? So highest base number base is what? 77. So take it, 77 to the power 1. So we can write it 7 to the power 1 into 11 to the power 1. Simple. So now compare, take the numerical power in the numerator, right? See, whenever we are going to take numerator and denominator, so I will take the numerical power in the numerator and variable power in denominator. It is clear. So we can say that 77 power 1 here is z. So 1 upon z is equal to what? 7 to the power 1, 7 to the power x. So 1 upon x. Then plus 11 to the power 1, 11 to the power y. Right? So simply we can say that 1 upon z is equal to xy. See, find the value of z. So y plus x. So simply we can say that after reciprocating, z is equal to xy upon x plus y. Clear? Yes? Clear? See, with this approach we will solve very good questions, right? So now tell me what would be the answer for this. Find the relationship between x, y and z. Just do this. Try this question. Yes, please. See, the first step is just focus on the base which have highest number, right? So highest number is 500. So just take it. So we can write 500 to the power 1. So we can break it into the prime factors form, right? So we can write it 2 to the power 2 into 5 to the power 3. Now clear? So just compare with the powers, okay. So 500 to the power 1, here 500 power z, okay. So variable power will come in the denominator, so 1 upon z is equal to what? 2 to the power 2. Here 2 to the power x, so 2 upon x plus 5 to the power 3 and 5 to the power y, so 3 upon y. So simply we can say that the relationship between x, y, z is equal to, or we can write it like 2 upon x plus 3 upon y minus 1 upon z is equal to 0, right? So this is the relationship between or among x, y, z. Clear? Now tell me what would be the answer for this question. Yes, please. See, 5 to the power x is equal to 4 to the power y is equal to 100 to the power 1. Nothing means 1. So I can write it 100 to the power 1. The base of 100 can be written as 2 to the power 2 into 5 to the power 2, right? Yes. See, 4 to the power y, we can write it 2 to the power 2y. No problem. So just compare. So after compare, we can say that here 100 to the power 1, here 100 to the power 1 also, okay. So upon 1. So must be equal to, see, 2 to the power 2, 2 to the power 2y. So we can say that 2 upon 2y plus 5 to the power 2, 5 to the power x. So 2 upon x. Simple. So we can say that this is cancelled. So I will get 1 is equal to 1 upon y plus 2 upon x. Now the question is asking what is the value of 2x plus 1 upon y. So this would be equal to 1. Simple. So B part is the right answer. Yes, B Bombay is the right answer. B Bombay is the right answer. So now tell me what would be the answer for this question. Very good question. See, the first step is focus on the highest base, okay. So highest base is 72. See, 72. So 70 to the power 1. So we can write it. So 72. So we can write it 8 into 9. So 8 means what? 2 to the power 3. And 9 we can write 3 to the power 2. 3 to the power 2, right? 3 to the power 2. Yes, we can write like this. Now compare. So when we will compare, so we will get 70 to the power 1 in variable 7 to the power z. So z will come in denominator, would be equal to 3 by x plus 2 by y. No problem. Yes. So just solve it. So we can say that 1 upon z is equal to LCM is xy. So here I will get 3y plus 2x, right? So after reciprocating, we can write it z is equal to xy upon 2x plus 3y. I can write this, okay. So just see, we need 5x. So just multiply by 5 both sides, right? So if I multiply by 5 both sides, so we can say that 5xy upon 2x plus 3y would be equal to 5z. Would be equal to 5z. So 5z is the right answer. D dear devil is the right answer. 5z is the right answer. D dear devil is the right answer. So I hope this thing is very much clear. Now tell me what would be the answer for this question. Yes, please. See. So directly we can say that 70 to the power 1, 2 to the power 2 to the power 3 into 3 to the power 2. So after comparing, I will get 1 upon z is equal to 3 to the power x plus 2 to the power 3 by x, 2 by y, okay. So z would be equal to what? xy divided by 2x plus 3y. Yes. So this time we need value for 7xy divided by 4x plus 6y. See, if I multiply both sides by 7 by 2, right? If I multiply both sides 7 by 2, so I will get what? 7 by 2z is equal to 7xy divided by 4x plus 6y. So 7 by 2 z is the right answer. So B part is the right answer. 7 by 2 z, B part is the right answer. Okay. Now tell me what would be the answer for this question. Yes, please. Very good question. See, here we can write this. Just try this question. Yes, please. See, we can write it 14 to the power x is equal to 6 to the power 2y, right? So 6 square 36. So this would be equal to 84 to the power z, right? See the maximum number of base. So that is 84. So 84 to the power 1 can be written as, right? How we can write it? 6 into 14. Yes, we can write it. See, here we can say that after comparing 1 upon z would be equal to 1 upon 2y plus 1 upon x. Simple. See, transferring 1 upon x. See, here is 1 upon x. So transfer 1 upon x to this side. So I can say that 1 upon z minus 1 upon x would be equal to 1 upon 2y. No problem. Yes. So now transfer 2y to the left side. So we can say that this would become, this will provide us 2y bracket 1 upon z minus 1 upon x is equal to 1. Now just multiply by 4. See, we need 8y. So just multiply by 4 both sides. Just multiply by 4 both sides. So we can say that I will get 8y bracket 1 upon z minus 1 upon x would be equal to 4. So 4 is the right answer. D, dear devil, is the right answer. Yes, D, dear devil, is the right answer. I hope the thing is very much clear. Now tell me what would be the answer for this question. Yes, please. Yes, please. See, x to the power 2a, y to the power 2b and z to the power 2x. So here we cannot say that which base is highest, no problem. But the relationship between x, y, z is given. X square is equal to what? I can write y to the power 1 into z to the power 1. So just compare the power. So here the power of x is 2, power of x is 2a. So we can say that 2 upon 2a would be equal to 1 upon 2b plus 1 upon 2c. Simple. Yes, we can write it. See, now by 2 cancel. So 1 upon a is equal to what? Take the LCM, 2bc. So this would be equal to c plus b, right? So just transfer a to the right side, okay? So, or we can say do the cross multiplication. So I will get 1 is equal to what? Or just do the cross multiplication, right? So we can say that here is what? 2bc is equal to what? AC plus AB. See, we need BC, AB plus BC plus CA in numerator, right? So we have AB and AC. So what is missing? So here the missing portion is BC. So just add BC both side. Just add BC both side. Okay. So we can say that AB plus BC plus CA is equal to what? Thrice of BC. Is this clear? So transfer this BC to the left side. So we can conclude that AB plus BC plus CA upon BC would be equal to 3. Yes, is this clear? Very good or very interesting question. So 3 is the right answer. Yes, 3 is the right answer. 3 is the right answer. A part is the right answer. A part is the right answer. Now tell me what would be the answer for this question. Yes, please. Try this question. See, directly we can say that 2 upon 2a would be equal to 1 upon 2b plus 1 upon 2c. Yes. So 2 get cancelled. So 1 upon a would be equal to LCM is 2bc. Okay. So c plus b. Just cross multiply. So 2bc would be equal to ac plus ba. So now just add BC both side. Just add BC both side. So we can say that AB plus BC plus CA would be equal to thrice of BC. See, here we need 12 BC. So what we can do? See, just transfer BC to left side. So AB plus BC plus CA is equal to what? BC is equal to 3, right? So just multiply both side by 1 by 12. Okay, so just multiply 1 by 12 in both side. So I will get what? I will get AB plus BC plus CA divided by 12 BC would be equal to 3 by 12, right? 3 by 12. So by 3 it is cancelled 4 times. So 1 upon 4 is the right answer. So C part is the right answer. Yes, C Chennai Express is the right answer. So I hope this thing is very much clear. Okay, so try this question. So tell me what would be the answer for this question. Yes, please. See, here we can write it 5 to the power x is equal to 3 to the power 2y is equal to 75 to the power z. So take the highest base. So highest base number is what? 75. So we can write it 75 to the power 1 is equal to, see, 25 into 3. So 3 to the power 1 into 5 to the power 2. We can write it. Okay. So after comparing, we can say that 1 upon z is equal to 1 upon 2y plus 5 to the power 2. So 2 upon x, right? So simply we can say that, see, z is equal to, we will get, so 1 upon z is equal to what? 2xy is equal to x plus 4y. Okay, so we can say that z is equal to what? 2xy divided by x plus 4y. Is this clear? Yes or no? So after comparing, we can say that k is equal to what? 4. So k to the power k means 4 to the power 4. So 4 to the power 4 means 64. So 64 is the right answer. 64 is the right answer. So just correct the option. 64 is the right answer. Yes, 64 is the right answer. 64 is the right answer. So my dear friend, this is all for today. So this is our official Telegram channel. You can join. If you have any kind of query, so you can WhatsApp your query on this number. Okay. So there is information for you. See, just go to the oliveboard website. See, just type oliveboard. So you will get, see, after reaching oliveboard website, you will get the interface like this. Okay. So here we are having restart, right? Restart offer in this 49% off. So code is start, right? So you can also check it out. See, if you focus or just click on the course section, right? So after clicking on the course section, you will get, so current feature is, there is a very important information, SSC Super Elite all English medium courses, right? So this is the best product, right? So just click on this. So you will get each and everything, right? So everything regarding to the SSC exam or any exam conducted by the SSC. So you will get each and everything from this, right? So you can click on the enroll. So you will get two options. If you are preparing only for SSC, right? So just go and let's suppose you have to opt for 18 months, right? So just apply the coupon code. That is what? Start, right? START, start. So apply. So you need to pay only 1733. Okay, so very less amount, right? So there is a good offer for you. And if you are preparing for the both SSC and railway, so combo pack is also very good, right? So here you can see start, right? So you will get in just 2039 you will get the both package, right? So you can check it out, these options. So this is all from my side. So thank you guys, thank you very much. Stay in touch with us. Thank you guys. If you haven't subscribed the channel, so please subscribe the channel, like the channel also. Thank you guys, thank you very much. Jai Hind.